Hi, this is Marty with Skincare Science, and welcome back to another video. All right, so in this video, I'm going to explain desmosomes, basically. They are a critical part of the epidermis, and as you can see, I left this here, and as you can see, I'm trying to get away from talking about the stratum corneum outside of the epidermis, just for my own personal reasons, in my study and as it connects to how I talk about the skin, how I talk about skincare. So that's why you'll see the E there with the epidermis and with that bracket, and then the stratum corneum labeled with the granular layer, spinosum, and then the basal layer. The reason why I'm putting granular and basal is, and there's nothing by spinosum, is because you'll see that in a lot of textbooks. Okay, so I want to kind of be on the same page as what you're mainly going to read and see, because I know that when I first started to study this, I was very confused because of the different names. Okay, so basal, remember, is a basement layer, and suprabasal are the cells that are above, but that's not really that important for today. So let me get right into it. Okay. So everyone knows, well, you should know what a desmosome is. They are basically proteins that are within the cells and outside the cells. Now, I will later on in videos talk about some of the skin diseases that happen as it relates to desmosomal dysfunction. And I'm not going to get into some of the confusing names, not confusing, but some of the higher level names. I'm going to try to keep it simple. Again, we're not in medical class. What we're doing is we're trying to gain a basic understanding, a bird's eye view, but dive deep enough to understand how chemical acids and products are able to be absorbed and provide efficacy and do their job, basically. Okay. All right, so how do I want to do this? All right, I think the best thing for me to do is I need to kind of stand over here and kind of draw in this area here, because I don't, like I said, I don't want to delete that. Maybe I'll change the size of that. It's pretty big. Okay, so what we have here is we have a cell, okay? It's like that. All right, and what I want you to envision is that this is in this area here, and it doesn't really matter that it's to size and how good my graphics are. That doesn't matter. But what we want to pay attention to is, and I'll draw underneath here, is the area in here. What I want you to think about is that they are really smashed together. In the layers of the skin, from the granular down to the basal layer, there are no spaces. Think of it as cheese, okay? It is just, there are no spaces, okay? When you come up to the stratum corneum, that's when there's spaces. So what are the most important two functions of the epidermis? Not what they do for us, but within the epidermis and how it's connected, what it does. Number one is sticking together. Everything must stick together. And two, communication. So the cells need to be able to communicate with each other, obviously. And oh, and by the way, I think in my other videos with regards to stratum corneum, it's not dead. And honestly, and I mean this too, I'm entitled to my opinion. And if I were sitting in front of the most prominent medical doctor, whatever, and they said that the stratum corneum is dead and they proved it to me, I would still say no, it's not. That's how convinced, and that's my hard line. It's not dead until the corneocyte exfoliates and lands on the ground and then is put under a microscope so that I can see that cornified cell. Then I will agree that it's dead. Other than that, it is alive and it is functioning and it is communicating and a part of our skin. Do not overemphasize the word communicating, okay, when I say that within the stratum corneum, all right? It's just a belief system I have, then that's it. All right. So that will put us on the same page. There is no argument, there is no debate, because you can't debate me on whether the stratum corneum is dead because of what I just said. Does that make sense? All right. Okay. So, and I don't get a lot of comments. I just get phone calls, texts on my phone, and I get emails. That's how people communicate with me on these videos. All right. Okay. So remember back to this. So this is a cell here, and this is an area between them. So this and this is a cell membrane. Okay. And well, this is the same. So we got that? Okay. So we're talking about, I'm going to use a different color. Use, I don't know, pink. Okay. So we're talking about this and this, and then the space in between. So throughout the epidermal layers, okay, and I'm not going to get into where yet. Maybe I'll do a video on it. What we have is, we have basically, I don't know, it's extremely complicated, but just think of it as a pipe. You know what I mean? Here, 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 and here. Okay? And then, just so I can differentiate between the two, this cell has other pipes on it. Now remember, this is exaggerated and there's no real space. I mean, basically what it looks like, if I were to draw this again, is this right here is that. This is that. And so I'm in between that line there, but you can't see it there. So throughout the epidermis, this is how the cells are connected, through these proteins. There are different types of these throughout the epidermis, and they are specific for the layer that they are. The reason that is because as a cell moves from the basal layer, it goes on a programmed death from bottom to top. They need to change in their connection and strength and composition, molecular composition, and they do. So what ends up happening is you have this crazy, and by the way, some of this research is like 10 years ago, okay? So different subject, but just so you know, it is. It's like some of this understanding is really very recent. And most of the studies of the skin started in 1900 and came all the way through, but really over the last 50 to 60 years is when it just exploded. You know what I mean? So this is what's going on. This is how they're connected. All right. As the connecting desmosome proteins, connecting points that look like this start to change from the basement layer to the granular layer, they change in composition. But here's the most important thing. And I'm not going to get into filaments either. Well, I can, but I'll just touch on it really, really close. Okay, if you've ever heard of filaments, I'm going to draw them right here. They basically look like this. And they're compact and they're throughout the whole entire epidermis. And what they start to do, the filaments, is they start, and this is something I need to discuss later, but they start to align and become stratified with the stratum corneum. And stratified, remember, just means in layers, okay? And that's why you'll have the skin will kind of look like that, column, box, flat, stratum corneum. You see that? So that is why everything in this layer is stratum germinatum, spinosum, stratum granulosum, stratum corneum. That's how that kind of works. All right. Okay. So back to this, kind of forgetting about the filaments, just to go back because I get sidetracked. Sorry, let's just stick with the desmosomes. So if we're dealing with this inner space here, that's how they're connected, and this is how cells communicate with each other. Right. Now, the miraculous thing about the layers underneath the stratum corneum is how they slip and slide and move up to become a part of the stratum corneum. That's another video in and of itself. All right. So how and what happens to these cells as they're interconnected like this? What happens as they reach the stratum corneum? Well, that's the cool part, and I've talked about that before in other videos. And basically what happens is this. As these cells come into the granular layer and reach up into the compactum area, stratum compactum of the stratum corneum layer, they basically, and I'm going to go ahead and draw this, crack open, and the desmosomes that were inside that have now changed through their molecular structure are going to create, are going to, well, how can I say this? Are going to become less adhesive. So as it relates to adhesion, what I'm going to do is I'm going to draw a couple of lines here to show you basically what's going on. And how can I do this? Make it simple. Let me do it this way. So if I draw this line here, see this? Okay, and I color this in. This is adhesion. See the connecting? This is adhesion. And as you come up the epidermis, these change in molecular structure, they become different. Okay? And the adhesion lessens. The structural cohesive nature of the molecular structure of these proteins within the cells, and as they crack open and connect to each other, have less adhesion due to the skin's demand on structural integrity to help us keep water in and protect us from the environment. Okay, I hope that makes sense. And what I would like to say is this. This is all genetically determined, and all skin-related diseases are connected to desmosonal adhesion and how fast, or I should say, nature's intended speed with which a cell divides from the basal layer and moves up into the stratum corneum to ultimately be, or a part of, the exfoliation process. Cells in the epidermal layer are connected through a matrix of proteins extruding out from the cell membrane to lock. As the cells move to become a part of the stratum corneum, they change. As they change and move up into the stratum corneum, what is inside the corneocyte, okay, or the cell, it cracks open, loses its nucleus, becomes completely, or I should say 85% of moisture that was in it is now gone, and it is almost completely dehydrated. And those desmosomes that were inside of it now become a part of the cohesive binding properties of the stratum corneum, and they look like this. Okay? I'm not going to discuss gap junctions. Gap junctions are what's happening in between the intercellular space of the stratum corneum. I'll discuss that later. Sorry for the tone, but to articulate this, it is really, really hard. And I want you to know, I also limit the depth of my study because it becomes so difficult to truly understand what's going on. So what I do is I study, and it takes hours and hours of reading some paragraphs I'll read over and over again, but it just becomes so complicated that a paragraph has like 10 words in it, like 5 or 6 sentences, and there'll be 10 words in it, and you have no clue what they mean. And when you clear that word, clearing it is understanding its definition, that's another 100-page book. So that's how complicated this is. So sorry for the tone. I try to make it simple. I'll go over filaments and gap junctions in another video, but this is how the skin functions, and I am so far past a recap, and I apologize. Oh, and by the way, to end this video, glycolic acid, lactic acid, and salicylic acid work on the desmosomes and the intercellular proteins in space. TCA and Gesner and protein coagulating acids work on all of it. Okay? That's what frosting is. All right? Salicylic acid cannot frost. It doesn't have the chemical structure to do it. It cannot. What that is with an excessive amount of salicylic acid applied to the skin and it has a chance to evaporate, meaning the liquid from the crystals, you will see the crystals. How do you know you're looking at salicylic acid crystals? Because it will flake away. You can brush it away. Okay, very much like salt water brushes away from your skin, it's identical. Protein coagulation, what happens with frosting and TCA and Gesner, you cannot, because you cannot detach the skin or cells after they have been coagulated or cooked by the acid until they are ready to exfoliate. Okay, now I'm winded. All right. I hope that this explains a little bit, and I'll probably have to discuss it again at some point, more in depth, or maybe I need to discuss maybe what's going on here at this layer, which I will. And I hope this helps give a little bit more education. Again, sorry for tone and speed. I'm trying to make these a lot shorter. Anyway, this is Marty with Skincare Science, and I hope this helps. Hope you enjoy all the videos, and we'll see you in the next one.